Let's do acids and bases past exam questions in the simplest way possible. Calculations. And you know what? You deserve every single mark in these questions. I am nation. Here we go. Let's do this past exam question right here. 7.1.5, they want us to calculate the pH after complete ionization. They give us some information before this question. They are saying sulfuric acid has a concentration of 0.1 mole per dm cubed. Now, firstly, since they are looking for pH, let's write down the formula for pH. pH is negative log concentration of H3O plus. So when we do pH calculations, we are going to need to find the concentration of H3O plus. Remember, the square brackets represent concentration. Let's refer back to our information. The information says sulfuric acid has a concentration of 0.1 mole per dm cubed. So that will mean to get H3O plus concentration, we're going to have to use the concentration of sulfuric acid to give us the concentration of H3O plus. And what's the concentration of sulfuric acid? 0.1. So that's 0.1 for sulfuric acid. What about H3O plus? Remember, from these two steps of ionization, H3O plus, we got two of them. So we have two H3O plus ions, this one and that one. So we take this value 0.1 and multiply it by 2 because we have two of these. Therefore, the concentration of H3O plus is going to give us 2 times 0.1, which is 0.2 mole per dm cubed. Then we substitute that into pH formula. pH is going to be equal to negative log of 0.2. Use your calculator and round off correct to 2 decimal places. You get pH is equal to 0.70. And checkmate. Next customer, please. Question 7.2. 1.2 grams of anhydrous oxalic acid. Oxalic acid is H2C2O4. Anhydrous simply means no water. So it's a scientific term to mean this H2C2O4 has no water. Now, since it has no water, we're going to be dissolving it in water to make a solution out of it. So let's read from the start with that knowledge. 1.2 grams of anhydrous oxalic acid is dissolved in water to make a 50 cubic centimeters solution. 7.2.1, calculate the concentration of oxalic acid. Now, at this stage, guys, we need to be aware of 4 types of calculations, the ones that come over and over again in acids and bases. 4 types of calculations. Number 1, pH calculations. Number 2, titration. Number 3, dilution. Number 4, quantitative aspects of chemical change. And which calculations are 7.2.1? Let's see. We are given 1.2 grams. That's the mass. We are given 50 cubic centimeters. That's the volume. And they are looking for concentration. That's C. So this has to be quantitative aspects of chemical change, the basic calculations you learned in grade 11. So we go to the formula page and look for a formula that has the mass, the volume, and concentration. And this is the one right here. That C is equal to small m for mass over big M for molar mass. We are going to get this from the periodic table. Multiply that by volume. Remember, we are doing this for H2C2O4, oxalic acid. Let's work out the big M first, the molar mass, using the periodic table. So that's H2C2O4. So we're going to need the molar mass firstly for hydrogen atom. Here it is, it's going to be 1. We'll multiply it by 2 because we have 2 hydrogens. C2, that's carbon right here. Number 6, molar mass of 12. So that's plus 12 times 2 carbons plus now the oxygen with a molar mass of 16. 16 times 4 oxygens. Use your calculator, you will get 90. Okay, let's write our values down here. Small m, 1.2 grams. Big M from the periodic table, we just got 90. And the volume, From the information, that's 50 cubic centimeters. We're going to have to convert it into decimeter cubed. How do we achieve that? Oh yeah, we divide by 1,000. If you want to write it in scientific notation, you can just say it's 50 multiplied by 10 to the power negative 3. Is the same as division by 1,000. Substitution time. Into the formula, we're going to say concentration is equal to 1,2, that's our mass, over the molar mass of 90 times the volume of 50 times 10 to the power negative 3. Use your calculator, you're going to get the answer of 0,27 mole per dm cubed. Remember, this is the concentration for oxalic acid, H2C2O4. And checkmate. Now, question 7.2.2, 7 marks. Now, these 7 marks, guys, are not supposed to get any one of us nervous. 7 marks are supposed to get us excited because this question is going to be so easy you won't believe it. We break it down into number 1, quantitative aspects of chemical change. How will you know it's quantitative aspects of chemical change? You will know when they are asking questions like mass, concentration, volume. It can also be about pH as well. But with pH, you will just know because they are very direct about pH calculations. They will just say find the pH or something related to pH. But in this case, we are not going to be doing any pH calculations in question 7.2.2 because we already did that in question 7.1.5. So pH is out. Titration, that's another type of calculations, and this is the formula for titration. Dilution, and this is the formula for dilution. So this question, we're going to be breaking it down into quantitative aspects, titration, and dilution. Let's read the information, then break the question down into those types of calculations. So here they are saying learners dissolve X grams of sodium hydroxide, that's the base. So on the left side here, we see a beaker, and inside this glass beaker, we have sodium hydroxide. We don't know its mass, so they're just calling it X. We take this X grams of sodium hydroxide from the beaker and put it inside this flask. With some water, we make a solution. Let's read up there. To make a 2 decimeter cubed solution. That's the volume. So inside here, inside this flask, we have 2 decimeter cubed of sodium hydroxide. Now watch this. Let's start to break this down. Since this whole part so far is just talking about X grams, that's the mass, 2 decimeter cubed, that's the volume of sodium hydroxide. Usually small m and volume will go together with what? With the molar mass. So everything inside this box will be quantitative aspects of chemical change. It's according to these 4 types of calculations, quantitative aspects. Let's read on to see other parts. Now, after making a solution of 2 dm cubed right here, they transfer 25 cubic centimeters. Remember, this 2 is in decimeter cubed, which is actually a bigger volume than 25 cubic centimeters. So they transfer 25 cubic centimeters of sodium hydroxide solution to a volumetric flask and added distilled water. Whenever they add distilled water, guys, that's dilution. That's why they are saying to make a diluted 100 cubic centimeter solution. So from the quantitative aspects box, we are going into the dilution part of the question. So this orange box here is dilution. We are adding distilled water, that's pure water, to dilute 25 cubic centimeters of sodium hydroxide base, the one we took from the box before. And remember, the dilution formula is C1V1 C2V2. We'll explain the formula as we continue with the question. So far in this list of calculations, we have quantitative aspects, dilution, and what's missing is titration. Let's continue reading. Under this diagram, they are saying they titrate. Now we are titrating, guys. After diluting inside the orange box here, after diluting, they are taking some of that dilute solution of sodium hydroxide and titrate it. Remember, a base is only titrated with an acid. Let's see. They titrate 43.8 cubic centimeters of the diluted sodium hydroxide solution against oxalic acid. prepared in question 7.2.1. In question 7.2.1, we got concentration of 0.27. Let's trace the question so far. First box, quantitative aspects. Why? Because it's talking about the mass, the volume of sodium hydroxide, its molar mass. The orange box is talking about distilled water being added. That's dilution. Now, the next information under the diagram, they are talking about titration. So we need a titration box. Nazo, and the formula, remember, is CAVA over CBVB is equal to NA over NB. That's titration formula. Now, this balanced equation is actually representing the whole titration. This is the acid, this is the base. On the right, we have the products. What are they looking for in the question? Let's see. They are saying calculate the mass, which is X grams of sodium hydroxide. That was used to make the 2 decimeter cubed solution. When you trace the whole story, can you guess, are they talking about the first box or the second box or the third box? Maybe you guess right. They are talking about the first box where there is X right here. That's what they are looking for. The mass, which is small m. But how do we do this question? Very important, guys. We do this question in reverse. We start with titration, then dilution, then finish it off with quantitative aspects where we will be finding the X value. Titration first. If you like, you may do a table of information where you're showing you are titrating an acid and a base. The acid is H2C2O4. Remember, the base is sodium hydroxide. According to titration formula, we're going to need CaVaNa for the acid, and for the base, we are going to need CbVbNb. Okay, let me move this. So titration is the last part they spoke about here in this last paragraph. Let's write the values. They titrate 43.8 cubic centimeters of the diluted sodium hydroxide. So sodium hydroxide is the base right here. Its volume is 43.8 cubic centimeters. Remember, in titration, there's no need to convert cm cubed into dm cubed. So they titrate this amount of sodium hydroxide against 25 cubic centimeters of oxalic acid. So for the acid, we write 25 cubic centimeters. Prepared in question 7.2.1. Let's see what we got from question 7.2.1. Here is question 7.2.1. We got 0.27 concentration of the acid. So we write 0.27 right here. Okay, what are the other values? If you remember the theory part of this, the solution of known concentration is called standard solution, which is the acid in this case. So we are going to find the unknown concentration of sodium hydroxide, the base. What about Na and Nb? Na and Nb are the mole ratios from the balanced equation. Let's see. Mole ratio of the acid here in the balanced equation is 1. The base is 2. See that? 1:2. Then we substitute this into the formula. Let's do that. Ca 0.27, Va 25. So that's times 25 over Cb, that's what we are looking for. Vb, that's 43.8 is equal to Na, which is 1, Nb, which is 2. So that's 1/2. Next, we just cross multiply, then make Cb the subject of the formula. Let's do it. This is how we cross multiply. Let's divide both sides to make Cb the subject. Now, so use your calculator. You will get Cb is equal to 0.308 mole per dm cubed. So the titration part gave us Cb is equal to 0.308 mole per dm cubed. Remember, we are working in reverse. Now we are going to dilution. Okay, let me clear this up and set aside titration box. We are done with it. Dilution, here we come. C1V1 is C2V2. Explanation. Remember, guys, when you dilute something, you are adding water. And before you add water, you have your C1. That's the first concentration. This is before on the left here, before dilution. On the right, that's after dilution. C1V1 before diluting, C2V2 after. Now let's see the orange box. Remember, they took these 25 cubic centimeters and added water to it. So before dilution, we are working with V1, which is 25 cubic centimeters. C1, let's see, we don't have any value of the concentration of sodium hydroxide before it was diluted. So we're just gonna write C1. V1, that's 25 right here. Remember, you divide it by 1,000, which is the same as multiplying it by 10 to the power negative 3. But otherwise, you can just write 25 over 1,000. Okay, concentration of the base after it was diluted. Let's see. Remember, titration came after dilution. So meaning this value we got so far, CB, that's our C2. It's coming after diluting, 0.308. Now V2, let me explain. When it comes to V2, we are referring to the volume of whatever you are diluting. So in this case is the volume of sodium hydroxide plus the volume of the water you are adding. That's gonna give us diluted solution. Let's see from the information if we have this V2 diluted solution. And we do have that diluted solution. It's 100, guys, cubic centimeters. You see 100 right here. So in the place of V2 here, we are going to write 100 divided by 1,000 because it's centimeter cubed, or just multiply it by 10 to the power negative 3. Let's now make C1 the subject of the formula. We are going to divide both sides by 25 times 10 to the power negative 3. Now, so using your calculator, you're going to get C1 is 1,232 mole per dm cubed. And by the way, guys, since this formula is indicating that we can still cancel out, you might even want to just keep the centimeter cubed the way they are, not necessarily converting. Okay, so from our dilution box, the orange box, we got the concentration C1 of 1,232. Now the final box, remember we are working in reverse. Now we are in the quantitative aspects, the beginning of the story. Okay, let's do it. In the quantitative aspects box, they want us to calculate X, which is the mass of sodium hydroxide. That's where we go to the formula that has the mass, the volume, and the molar mass, which is C is small m over big M times V. Remember, is the concentration of the base, which we got in the dilution box, the orange box. We got 1,232. So in the place of C, we write 1,232. Small m is what we are looking for over the molar mass of what? Sodium hydroxide. For that, we refer to the periodic table and find the molar mass of sodium hydroxide, which is equal to, let's go sodium. Here is sodium, which is 23. It's only one sodium, that's 23, plus oxygen, that's 16, plus hydrogen, molar mass is 1. So this is a total of how much? 40. So the molar mass is going to be 40. What about the volume? They told us the volume here inside the quantitative aspects box is 2 dm cubed. So there's no need to convert it. It's already converted. 2 dm cubed. Let's cross multiply to make m the subject of the formula. So we're going to get 1,232 times 40. Now, so use your calculator. You're going to get the mass as 98,56 grams. And checkmate.